మొహమాటంగా మాట్లాడు, తర్వాత బాధపడదు. చేసుకోవడం బాగుండాలి, వచ్చి చేసుకో, చూడు, నెల 2 నెలలు చూడు, నీకు ఏదైనా కాలేదనుకో సార్ని అడుగు, సార్ మరి ఏంటి మాట
A very good evening, everyone. Am I audible to all? Hello, everyone. Okay, so we will start our class. Anyone having any doubt in any question? Yeah, sorry, actually, I was setting up my whiteboard, so that's why I was not audible. Now we will start the session. I asked you all if you have any doubts, so you can ask it right now. Considering you don't have any doubts, we will start on with the new question today. Okay, so the question for today is, you have been given a number A and its power n. Okay, I am pretty sure you all are well aware of this particular question. Yes or no? How to find A power n? Yes, okay. So can you think of this problem in terms of recursion and tell me, can you do it using recursion or not? Everyone getting me right? Okay, let's try. So you all give it a try. I'm giving you a minute. Think of it and then tell me if you're able to do it or not. Clear? Okay, I got one result or one answer. So I'll just elaborate right now, like what's happening in this question. If you will break it down, it will be like A dot A to the power n minus 1. Clear? Yes or no? Yes. So when you have the result for A of n minus 1 and you multiply A to that, you will be getting your result, right? Okay. Following this approach, I guess you can get the idea. So I'll just write here int guys, just give me a minute. I'll restart this whiteboard. Not sure what problem it is facing. And just give me a minute also. Yes, am I audible? Let's just see if it is working out or not. I'll write the function int power and you will be given two variables. One will be your value A and the other will be your value for n. As per the definition, we will be writing here return A multiplied by you are assuming that the remaining answer your power function is giving you, that is power of A comma n minus 1. That's it. Everyone, are you clear or not? Clear. Okay, great. Now, can you tell me the base condition where this function is going to stop?
If power double equal to 0.
If power is equals to 0, correct. That is, if at any point your n becomes equal 0, in that point, you know that any number to the power 0 returns you 1, correct? So I will be returning 1 from here. And your function definition is done. Clear, guys? Okay, great. Can anyone think of a better approach than this? Because, okay, before finding the better approach, you all just analyze and tell me the time complexity for this. Clear? I'm giving you a minute. Tell me the time complexity for this, okay? Yes, anyone figured out the time complexity? Order of n. Okay, I'll just write here the recursive equation for this. It will look like, you know, that this is going to be order of 1. Again, order of 1. And this particular function will take, you can say, not order, it's t n minus 1. And multiplication is also going to take order of 1 time. If we'll solve that, it will come out to be t of n is equals to t of n minus 1 plus 1. If you all have solved this, you must have got the answer for this as order of n. Bhuvnesh, I hope you got it that it's not going to be log n, it's going to be order of n. Clear? Yes. Now, finding a better idea to this, always whenever there is a power, like let's suppose your number is 8 to the power 12. Okay, since it is an even number, you can divide it into two parts, that is a to the power 6 multiplied by a to the power 6. Further, this can be broken down to a to the power 3 multiplied by a to the power 3. Same goes with this. And this can break down to a multiplied by a, that is the division of powers, and an extra a since it is an odd number. Are you guys getting me? Yes. So if you observe here, if we are able to get the value for a to the power 6, we will be able to get the value for a to the power 6 also. Getting it? This a to the power 6 also. If we are able to get the value for this a to the power 3, we will be getting the value for all the remaining a to the power 3s. And a value to we already know. So instead of we multiplying for like we calculating the value for like 1, 2, 3, 4, 5, 6, 7, 8, and 9 times, if we just do it for 3 times, our answer is going to get, like, we are going to get our answer. And same thing goes for all the odd values as well. For odd values, like I can take the number as 13. 13 will be nothing as a multiplied by a to the power 6 into a to the power 6. That's it. And then again, the same cycle will continue. Getting this? Everyone else in the class? Okay. Now I will write the function definition for this one also. It will look like int power. Here you will be having int a and int n. So the way that we discussed, it can be written as return power of a comma n by 2 multiplied by power a comma n by 2. Obviously, you know that you need to write the conditions for odd and even also. Yeah, correct. So you can write it here. If n modulus, you can ignore my sorry, this caps log and that thing, because I'm writing somewhere n as capital and somewhere n as negative. Oh, not negative, I mean small letter. If it is equal 0, you have to return this. Otherwise, else you have to return a multiplied by power of a comma n by 2 multiplied by power of a comma n by 2. That's it. The condition remains the same, that at any point your your n becomes equal 1, because you can see here you are dividing it right now, correct? Sorry, mod, or n becomes 0 or 1, anything. You can return, if you will write here n equal 1, you can return a, otherwise you can return from here 1. Clear, guys? Yes. Will this function work out? Okay. Can you tell me the time complexity for this? Can anyone tell me the time complexity for this? First calculate it and then tell me. No, don't just like guess and tell me. Calculate it properly and then tell me what will be the time complexity. Okay, I have got the answers. So yeah, you all guys are thinking it right. It's gonna be T of n, considering remaining all the conditions as 1, that is order of 1. But at this point, if this will get execute, both of these function calls are gonna execute. So it's gonna be 2t of n by 2. Either this will execute the if condition or the else condition. So we can just simply write it as 2t n by 2. If you solve this, you are gonna get your result as order of n. So in the previous situation also you were getting it as order of n. Now also you are getting it as an order of n. So what makes the difference? Why are we not going with this approach? Why am I telling you to take these even and odd conditions and follow this approach? Any ideas? Anyone having any ideas? All quite. Okay.
In the previous case, we were doing for just one case, like even number. This we are taking odd, even, both.
No, but our previous case was not even distributed with two values as odd and even, right? It was just bothered about n. And continuously we were reducing the value of n and we were getting our answer, right?
Yeah. Okay.
Does it even bother about odd and even? No.
No. Yeah. So.
Earlier we were calculating the repeated but here example. No, it's not getting calculated once. That's the problem. According to the function calls that we have done, Kishan, here, you can see we are doing the two function call. If this function call is for a to the power 6, this one is also going to be for a to the power 6. It doesn't make any sense, right? We are calculating same things twice. Then comes the next solution. Int power. Again, the parameters are going to be the same. Just the place where you are like calling these two times, I will take a variable here. Int x, and this will calculate my value for power a comma n by 2. Once this is done, I will check if my n modulus 2 is equal 0. If that is the case, in that case, you need to return x multiplied by x. Otherwise, in the else situation, you need to return a multiplied by x multiplied by x. Everyone, are you clear?
Ma'am, I have a small doubt.
Yes.
In this just previous one, when you wrote 2t n by 2, so it will be like log n, because it's n by, next time it will be n by 4, it will be n by 8. So
But it's 2t, right?
So 2 will cancel out.
Why it will cancel out?
No, so how do we get to on? I was thinking it was log n.
That's why I've told you to solve these equations on your own. Here it will be 2. This will be breaking down to 2t
N by 4.
n by 4 plus 1 again, which ultimately will give you 4t n by 4 plus 3.
Yeah, 3.
Have we solved this type of recursive equation?
Yeah, we have done that.
What?
Yeah, we did that couple of classes ago.
Okay. Here it will be 2t n by 8 plus 1
One.
and plus 3 will remain here. You'll be getting here 8t n by 8.
Plus 7.
Yeah, right. Plus 7. When you will be solving this, I'll just write the recursive equation for this. It will be 2 to the power k t of n divided by 2 to the power k plus this will be 2 to the power k minus 1. Are you getting this?
Yes, yes.
You can see here when we will compare n equals to 2k. So you will be getting 2 to the power k value as n. Replace everywhere where 2 to the power k is there. So this will come out as n t n by n plus n minus 1. Overall, if you will see, you are going to get your answer as 2n minus 1, or in an overall scenario, you can say it as order of n. Clear?
Yeah.
Good. In this particular equation, just one thing will change. Since you are like calling your power function only once, it will look like t of n is going to be equals to t of n by 2 plus 1, the remaining order of 1 situations. When you will be solving this, or you have already solved it, you will be getting your answer as order of log n. So changing just the order of how we are calling a recursive function, that also can change a lot to your particular function definition. Clear? The previous function definition was exactly the same, but function calls were a little more. You were getting a lot more time complexity, but here you're getting it as an order of log n. Clear, guys? Yes. Okay, that's great. We'll see next question. You have been given, I guess this is the proper third question of your recursion. So array of n you have been given, and you have been given the values as 3, -4, 8, and 10. These are the 4 values given to you. You have been given k equals to 9. You have to check if there exist any numbers in here whose sum becomes equal k. Clear? Can you tell me any set of numbers from this particular array whose sum will be equals to 9? If it exists, then you have to return true from your function. If it does not exist, then you have to return false from your function. Clear, guys? Okay. Can anyone tell me those numbers if they exist? Good, Vishnu. It do exist, and the numbers are 3, -4, plus 10. It gives you 9. Hence, this particular function should return true for that. Clear, guys? How can we get that? Anyone having any brute force approach idea in their mind, no matter what, they just tell me if it will work out or not, and you can tell me the solution if you have.
Ma'am, the brute force would be like having a for loop going from 0 to n and keep on adding the values until it matches k.
You
If
try to perform your approach manually and then tell me if it is working out or not.
okay,
Clear? Like one by one adding the numbers. You are saying that first we will take 3, right?
yeah,
3 is not equals to k. Now we will again add -4 to it. So it will become -1, correct?
correct.
-1 is again not equals to k.
Yeah.
Now it will move to 8. Once 8 is added to -1, you will be getting it as 7, correct?
Yeah.
Which is again not equals to 9. And when it will move to 10, 7 plus 10 will become equals to 17, which again is not equals to k. So at the end, you will be getting it as false. But as you saw, the answer should be true. Getting this?
Yeah.
Yeah. So this approach will not work. Okay, so I can solve by linear search. Aman, again, I did the linear search right now. It is not working. Okay. Maybe we need to find the sub array. Sub array or subset. Sub arrays are like continuous. Okay. This is your first sub array. This is your second sub array. This is your third sub array. And this is going to be your fourth sub array. Next sub array will look like -4, 8, -4 and 8, -4, 8 and 10. The other way around, 8, 8 and 10. And the last is just 10. Considering all the subarrays, it's not possible because it is like a, for subarrays, yeah, for subarrays, it's like sequential order. It's sequential. Clear? And we don't need our answer as in sequential manner. It may be non-sequential as well. For that reason, you need to take subset. Clear? Now, what is a subset? Anyone in the class who has no idea what subset is and what ma'am is talking about? Yes, guys. What is a subset? I want a one-line definition from you all on the chat box. Okay, so I have got three answers, all possible combination of elements, all possible combination of values of an array. Subset contain list of elements in okay, part of bigger group of elements. How many subset does an array of n size can have? You have an array here of n size. You can say the size is like 4. So how many subsets are possible? 1. Vishnu, are you sure?
So size 4 is only 1. 3 would be 3.
No, 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 no. I am asking, you are having an array of size 4. How many total subsets are possible? You're not getting my question?
Yeah. So containing various elements like element 1, element 2, element 3, and element 4 all.
Right. Basically, I'll just give you here what subsets look like. It starts from an empty subset, like no element taken. Next, it will start from 3. We take 3. Then we take 3 and minus 4. We can take 3 and 8. 3 and 10. Okay. After that, coming on to the size 3. So 3 minus 4 and 8. It will be 3 minus 4 and 10. At every point you can observe the next number we are taking, it's our choice. Either we can take it or ignore it. Correct? Like in this, we took 3 and minus 4, then we ignored 8 and we took 10. So every time we are either taking a number or ignoring a number. So for every number, we have two choices in the subsets. Next will be ignoring 4. So it will be 3, 8, and 10. Clear? Even the complete set will be taken into consideration. 3 minus 4, 8, and 10. Clear, guys? And next will be taking minus 4. Then you have minus 4 and 8. Next you have minus 4 and 10. How many total subsets has been there so far? Anyone can count and tell me? Yeah, count it and tell me how many numbers. 16 so far. So that is the rule of subsets. If you have an array of size n, you are going to have 2 to the power n number of subsets. Why so? Because as I told you, at every point you have two options, either to take a number or to ignore a number. So considering all the time you have two choices, it's always like 2 to the power n. Clear? Okay. Yeah, amongst these subset, like you now know that you have to find all the subsets. Then amongst all the subsets, you have to find the one which has the sum equals to k, and then you have to return either true or false. Clear? So for finding all the subsets, obviously you can now consider it will take you order of 2 to the power n time. Yes or no? Yes. How can we find the subsets? Anyone having any idea how to write the function for that? Obviously, you know that you cannot write a for loop for 2 to the power n, right? So you need to think something in terms of recursion. So just think it, and if you are getting any ideas, you can just share it with me. Okay, I'll give you 2 minutes of time.
Ma'am, can I just think? I mean, what I thought is that pick one element, and regardless of whether it is behind or forward, we'll take all combinations. For
How?
so, for example, if I pick, for example, 3, then okay, yeah, 3 is simple. It's like a linear search.
It's
Uh,
not a linear search. You can see here 3 and 8 are there, then 3 and 10 are there, which are not linear.
Yeah, no. So one thing I'm thinking is that, like, let's say pick any random number, and then starting from the beginning until the end, ignoring the same number, we will iterate and then print that
But
combination.
see, Vishnu, you are telling me this only for 3, right?
No, even if suppose I pick 8, I will start
No,
from
no, just
0.
just hear me out.
Okay,
You are
sorry.
doing these individual for loops for every individual element, right?
Yeah,
But you know that total number of elements in your array are going to be n.
yeah.
How can you write n number of for loops without even knowing what n value is going to be? Getting my point?
I mean,
That,
and we can find out array dot size. No, array dot.
but it is uncertain, right? Like, how can you write so many for loops for each and every individual element?
Yeah, for loop is not possible,
The
but
approach that you are saying, it's not possible, right?
yeah.
Yeah. So I'm just wanted you all to think about it, but in terms of recursion.
Okay.
Clear now?
Yeah.
Okay.
So even if I go with recursion, I pick any element and then start from the array index 0, and skipping the same number, I'll go all the way till the end.
Sorry, I didn't get you.
Oh, okay, let me write it, then it'll make more sense.
Okay, sure. Anyone else figured out anything as of now?
Ma'am, one thing I thought that sometime back you had done like a divide conquer, like divide, split from the middle, keep on dividing it, and then making combination with the remaining.
Okay, I'm getting you. Is there anyone else in the class who is thinking, or is it only Vishnu who is thinking about the solution right now? Okay. So you, as I told you all, at every point, you will either be picking the number or leaving the number. What my intention was saying that particular thing was, it will look something like this. Assume as of now, you are like at a starting point, 0. From this point, you're gonna start. Okay. Let's suppose you picked up 3 as of now. If you pick 3, you will be having 3 options. Either you can pick -1, you can pick 8, or you can pick 4. Let's suppose I picked up -1. Okay. Now, just a minute. At this point, I picked up 3. So my sum was 3 only. Now, at this particular point, I picked up -1. So my sum has got down, sorry, -4 it was.
Yeah, -4.
So my sum got down to -1. Again, you will pick up 8 at this point. Your sum will be 7 now. Now you pick up 10 at this instance, and your sum will boil down to 70. Here, when you picked up 3, you left out your 3 options that were picking -4, picking 8, or picking 10. So these 4 branches will also come out of this. Clear? Now, I will not go much into that, but this is done. At the end, your final answer here is 17, which is not considerable. We won't be going for it. Now, when you are here, like it will come back from this particular point, 17, to this point where it picked up 10. Now, since it knows that it is not getting the answer with 10, it will see, is there any other opportunity it can take instead of 10? But no, not possible, because you have already taken 3, -4, and 8 in the subset. Again, it will go back to 8. And from 8, it is having that opportunity that instead of taking 8, it could have taken 10, right? You guys able to follow? Yes. So here, if it would have taken 10, then the answer would have been 9, right? 3 -4 and 10. So you will be getting 9 as your answer. And from here, you will be returning true. Getting this? So it's not only recursion, it is also an example of backtracking. Getting this, everyone? You are recursively going and picking up the numbers. You are not getting it. Like if you are not getting the answer, you are backtracking and then seeing if the other possibility is gonna give you the answer or not. Anyone having any questions?
Ma'am, it's easier to say
But
different
difficult to do, right?
coding, yeah.
How did you write them? 10 and
That
9?
that we will see via coding. I was just trying to explain you the structure, how it is following. Okay. Are you able to understand the structure that I just wrote here?
Yes, ma'am, but I'm not getting 9 and 10, the last one.
Okay, you will be getting it right now. So you know that you have to either return true or false. So your return type is going to be Boolean. Subsets. You will be having your array in this. You will be having your size of array. K value, obviously. Total sum that you have taken so far. And also int index. Yes, int index for calculating the indexes. That is like where you are traversing as of now, because that will only give you the idea at which point you're traversing in your array, right? Okay. Now, as I told you, how to do that. So every point I told you that either you will be picking up the number or leaving that number. How is that going to happen? There will be two situations, either picking up the number or leaving the number. So I'll write here the situation subsets of array will be the same, n will be the same, and k in this case will also be the same because you are matching with the k only. If you are picking the number, that let's suppose the first number you are picking up, then your sum, like initially, let's suppose I am passing the sum as 0. And if I'm picking the first number, it will become sum plus array of index, right? Are you guys getting it? And next is index, whatever your index was, your index will now become index plus 1. Clear, guys? Or you will be calling the function as subsets array n, and k will be the same. Since you are not picking up the number right now, sum will remain as it is, nothing add on to it. But you are ignoring that number, right? You are not picking that up, but index should get increased since you have to go to the next number. So your index here will again be index plus 1. Clear or not?
Ma'am, I didn't follow this. Is there a division? No, like you put a
This particular thing,
yeah, yeah, yeah.
it's a pipe. It's a symbol of OR operation.
Okay, okay, okay.
Okay. OR operation is nothing but either this part will give you the answer as true, or this part will give you the answer as true. Overall, your answer will be true. But if both of these parts are going to give you the answer as false, then overall answer of yours is going to be false. It's a bitwise operator. I have not explained about it in the class so far, but we will be learning about it soon. Anyone having any questions what I have written so far?
Yes, ma'am. In the last one, you have written, you have passed a array n, k, and sum. Then here we have not written plus.
Aman, there is a lot of disturbance in your voice from your end. Can you say it once again?
Yes, ma'am. I'm not getting the last one. Or subset of array, comma n, and we have passed some plus we didn't get an array of index plus one.
This one or this one?
Yeah, last one, ma'am. We should write some plus array of index plus one.
But the point here is, Aman, that in the first case, you are picking that number of that, like from that index, okay? But
Yes,
the
ma'am.
second case is, you are not picking that number from that index.
Okay.
You are not adding that number to your sum. That's why the sum is as it is. It is not getting incremented with the array of index. Clear?
Yes, ma'am. Then in this case, what is the value of sum?
It depends, right? I'll show you the execution of this once, okay?
Okay.
Okay. And what will be the base condition for this? As soon as you know that you have taken all the numbers or the index has reached to index has become equal n, in that case, you need to return the check of yours, that is sum is equal k. If sum was equal k, it will return true. Otherwise, it's gonna return false. Clear to all? Yes. Now we will see its execution, as some of you are not actually getting what's happening. So we will see its execution, okay? No need to worry about it. Just give me a minute. Okay. So for the first time, let's see what I will pass in the subset function. I will pass my array. You all know the value for array values, like n will be 4. 4 values are there. K will be 9. Some value will be 0 as of now because I don't have any sum. And index will be also passed as 0. This is the initial thing which I'll be passing. Going into the function, it will check if at any point your index has become equal n. No, it's not. What it will do, it will call your this function, that is subset. I'll just write sub. Array will be the same. Your n will be the same. K will be the same. This time, if it has taken the number into consideration, which is at 0th position, that was 3 minus 4, 10. Sorry, it was minus 4, 8 and 10, right? 8 and 10. So now what will happen? Your sum will become 3 now, and your index will now increase to 1. Clear, everyone? Again, what it will do, it will again call this function. It will check if index is equal n. It's not. Again, it will be calling the same function, sub set array, and 4 will be the same, that is n. K will be the same. At this time, it is considering the number at array of index 1, that is -4. So when -4 is added to 3, it will result in -1. So your sum will become -1 and your index is going to be 2. Clear, guys? Okay, great. Now, again, it will go back again. It will check if index is equal n. Again, it's false. It will call the subset function. Array will be the same. 4 and 9 will be the same, that are n and k. This time 8 will be taken, so your sum will become 7. Okay, and your index will become now 3. When it will again check if index is equal n, that was 4. It's false. It will again call the subset function. And this time it will be array 4, 9, 17 when 10 is added. And at the end it is 4. This time when it will again call the function subset, it will check if index is equal n. This time this condition will be true, right? 4 is equal 4. Now it will check if sum is equal k. You have got the sum so far as 17 and your k was 9. It is not equal, so this particular function is gonna return false. That is false, it is gonna return to its previous function call as in result. Clear, guys? Now from this function call, this first part is executed, right? You can see this is just its first part, but its second part is still pending. Yes. So now it will execute its second part.
Ma'am, one
What?
question, ma'am.
Yeah, you can ask.
So index equal to n, you are telling, right?
Correct.
So index up to 0, it will start from 0, right? Up to 3 only, right?
Yeah, right.
But n, how it will be equal? It should not equal, right?
See, up to 3, it will add on the numbers, correct? Like 10 up to 10 it added, right?
Yeah.
After 10, it will become 4, index
Okay.
plus 1, and
Mhm.
that time it is getting matched.
Okay, got it.
Clear?
Mm.
This time when subset function will be called, okay, array will be the same, 4 will be the same, 9 will be the same. This time your sum was 7, right? And we need not consider 10 in our addition. This function suggests that our sum should remain as it is, only we should increase our index. Hence, we will have our sum only as 7 and our index will now become 4. Clear to all what is happening in the second function call? Yes. Aman, you can see this particular function call we executed, right? That's why we got 17. For the second function call, you can see we are not adding anything to our sum. So what was our sum in the previous function call? 7. So our sum here also will be 7 only. It will not change. Clear or not?
Yes,
Okay. This indicates, I'll just write here the conditions. You included included 10 in this particular call and you excluded 10 in this particular call. again, when this will match, sum is equal k, when index become n, this will again return false because your k was 9 and your sum is 7. So this is gonna return false. Clear? Since OR condition is there in the between, false or false, that means overall your answer is gonna be false only. So this is gonna return its answer to the previous function call as false. Clear to everyone? Yes. Now this will make another function call. Another function call is gonna be subset of array will be the same. 4 will be the same. That is n and k values will be the same. This time you should not add anything to the sum. Sum will remain as -1. And your index should increase to 3. Clear? So now index is equals to 3. It has one more chance to get executed, right? So again, it will make a call to its first function subset of array. 4 and 9 will be the same. This time, since you can see index is at 3, right? That is, you have to take the number 10. So when -1 gets added to 10, it will become 9. And this index will become 4. Clear? Is it clear or not? Yes. This time when it will check if 4 like index is equal n, answer will be true. Coming inside when it will check is sum is equal k, again that is true. So this will go up, returning the value as true. Okay, but this is still not over. For completion of the function, it will be making a call to its next function. From here, it will be getting false only. True and or false, you will be getting the result as true only. Okay, once you have got true, everywhere till the first function call, you will be getting your value as true only. And at the end, your function will be returning the value as true. I am not going into depth of each and every function execution, but I am just telling you the function calls until we get our result for this particular question. Clear? I hope you have got the idea how things are happening. The question was tough, but is the solution that much tough after the explanation? Is the solution tough? You can see it's just, I can say 4 to 5 line of code and you're done. Okay, then it's better after explanation. Correct. Like every time when you're new to recursion, someone explains you the process, it's a lot more better. For me also it was once. So yeah, just go through this particular question once. If any questions or doubts, you can just tell me tomorrow. We will discuss that tomorrow. Okay. Already I have extended the class a lot. So yeah. Are you guys enjoying recursion now? Nice. So we are having few more questions in the recursion. It will take almost a day or two. And then after that, we will move on to, I guess, linked list. Okay, everyone sorted. And yes, guys, so far, whatever question we have discussed, like all the questions on the binary search, and like I have also shared with you the stack questions, anywhere you feel like that recursion can be implemented, just try it. And if you're not able to do it, just come to me and just tell me that, ma'am, we tried to implement recursion because we felt like that it can be. Just tell us if like it's not going well as of now. Okay, because that's how you're going to practice recursion more and like more and more, and you will get better at it. Okay, then. So I'll just close the call for today and we all will connect tomorrow. So thank you for today's session and yeah, good night.